flow like this. Then current will flow like this. Current will flow like this. And it will reach to the same point, right? Do you think current can go here outside any place? Can leave from anywhere? No. That's why what we call closed path. So now I can say that there is a single path which is highlighted by the red arrows. Yani current will always flow this way. So there is only single path to flow a current. So we call it is a series circuit. There is no multiple path. Current will not flow any other path, only that path. So it is called series circuit. Similarly, look for the next circuit. In the next circuit, you will see that current, let's start from here. So current is flowing this way. Okay, then it has to go down. Then it will go this way. Then it will go up, right? Then from up to then here, then down, then this way, and then it reached to the same point again. So this is the only path that current will follow. There is no alternative for that. So it is also a series circuit because current everywhere is same. Okay, and this is another property of the series circuit. Only one path also, because it is only one path. So the current throughout all the component will be same. So same current is the property of a series circuit. Even if you look here, current will go this way through this resistance R1, then this way, then this way, then return here and reach to the same point. So this is the only path through which current will flow. There is no alternative path to flow the current. So that's why all the circuits which is shown here are series circuit. And also you can see here one more thing, that the components how they are connected. One end of the voltmeter is voltage source is connected to one end of the R1, another end is connected to that one, another end of R2 connected to R3, then it is connected to voltage source. This is something how they are connected. So current will be flowing this way. There is no other option to flow the current. So what we can say now, that a series circuit is one that has only one current path. Clear? What is a series circuit?
Yes, it's clear.
Okay. All right. I believe that you have some idea of series and parallel circuits in physics. Am I right? All right. Okay.
Yeah.
Okay, good. So, all right, let's continue now. So because there is only one path, the current everywhere is same. So this is now concluded. For a series circuit, we will be having everywhere same current. So now see this one. Now again, if I have an ammeter, which ammeter is a device which is used to measure the current. Okay, current meter you can say in local language, but technically it is called ammeter. So if I place that one here and see how it is placed, it is placed like the one end is connected here and another end of the ammeter connected here. Yani it should also be connected in series. So if I connect here, I will be getting 2 ampere, for example, here. If I connect here, same current will be here. If I connect anywhere ammeter in this circuit, I will be getting all the time same current, whether here, or anywhere. Because we have already discussed about it, that current in a series circuit is same. Either I connect the ammeter here, this place, or this place. All right. So the total resistance of a series circuit is basically, if multiple resistors are connected in series, so the total resistance will be the sum of individual resistors. What it will be? It will be the sum of individual resistors. All right. So let's see this example, girls. So now this is the same circuit. Now we are assuming some values here, and you can see R1 is given, R2 is given, R3 is given. They are asking what is the total resistance. So total resistance is, as I just formula says, is the sum of resistances. Yani we can say that R T, yani total resistance will be R1 plus R2 plus R3. All okay. Yani we need to add them and see. It's a good practice always to write the formula, then put the values. Because while you are calculating something, there are chances that you may get some wrong results. But if you are writing formula, it means that teacher can understand, students have complete idea, but there is some mistake. So you will be getting some step marks for that. Okay, so in order to calculate these articles, here you can see only R1 is in ohm and other two resistance are in kilo ohm. It means is that I need to convert one of them. So it's better only one I can convert, or you can convert any one. Lena already calculated, so it's okay. Yeah, it's correct. Or you can go this way. You are free, it is not bounded. Like it is now in kilo. So when it is in kilo, another one is 1.5, it is also in kilo. Another one is 2.2, all is in kilo. So simply when I will be calculating this one, I will get 4.38. And this is in kilo ohm. All right, now if you want to write it in ohms, so it is also you can also convert into this way. It is ohms. Okay, so it's so simple, you can calculate anywhere, either this or that, because we are not asking you. If we ask, okay, calculate the total resistance in kilo ohm, okay, then you are restricted. If we are just asking you to calculate, so you can calculate in ohms also, no problem. All right, so this is the total resistance. Now guys, if I ask you how much is the current flowing through R1, basically I am interested to know what is the current through R1. Okay, so Mariam calculated, it is 0.017 ampere. Shahad calculated. Okay, you can respond here in the chat. I am just looking. 5 calculated. All right. So the value are 0.017. Okay. Okay. What about others? Calculating. Okay. Lena. Okay. Lena, how much you are getting? Find the value, not the formula. Formula, it's just Ohm law. Calculate the value.
2.7 milliampere.
2.7 milliampere. 2.7 only? 2.7 was okay. Okay, 2.7. Okay, Mariam. No, Mariam is thinking now. 124380. Okay. See, you studied the series circuit. I am just asking you. You studied, na? I asked you sometime before that you study a series circuit in physics. You people said yes. Now I am testing just what you study. Okay, Batul. Sarah, it's okay. 0.16. Okay. Are you copying each other or just thinking yourself? Okay, 2.74 milliampere. Okay.
Maybe 17.64.
Okay, the very first thing about the formula. Okay, here it is a mathematical calculation, simple. So I want to know the first formula. Okay, tell me the formula. I want I1. What is the formula? Sarah, how can you forget the unit? Unit is ampere, simple.
V over R.
V over R1.
No,
Yeah,
it's C.
voltage
If you
over
see, if you
resistance.
say V over R, for example, V over R is basically general formula. This is general formula.
V over R1.
R
Yes,
total.
I am asking
Yeah,
specific. Okay, VS over R total.
R1.
Okay, so set. Okay, either this or this. There are two things, na? So one is saying R1. Okay. So most of you use the second version, in this formula, and you calculate. Most of you, I can see, because you are getting 0.17 something, okay? And this is here now. Now, how many of you are saying the first one? Okay, 5, then another, Mariam, okay. Lina, Amal, Zainab, Ali, okay. Okay, all right. Okay. Okay, what about the second one? How many of you are agree the second one is correct? One. Second one. Okay, Shah, Aziza, Batul. No, I'm asking second one is correct. How many of you are agree? Second one is correct. So Fatima, R equivalent is not like that. No, R equivalent is R total. Now, okay. Yani, I think majority is agree. Okay, Manar is saying we will use both of them. Okay. Okay, 5 is not saying. Okay. All right. This is confusing. Oh, all right. No problem. I will clear the confusion. What Mariam is saying is total in series second one. Okay, now, okay, just stop writing. Now listen. There is a reason. That's why I asked you. Okay, if I go this way, girls, 12 over RT, the first one. Okay, first one. So RT we have calculated 4.38. So how much is coming? 2.74. What it was? Milliamperes. All right. Okay. Let's go for the second option. 12 over 680. How much is coming? Yeah, just wait. Just let us just conclude this one. Then everyone will understand, inshallah. So if we go this one, we will be getting 0.017, I think. Yeah,
Yes.
ampere. All right. Definitely both the currents are not same, we can say directly. Even if I convert it into milliamperes also, let's convert it into milliamperes. So it is gonna be 17, this is something like that, okay? Correct? 70 milliamps. Yeah, 170, not 17, Mariam, because you need to multiply by 1000, 0.17. When you multiply by 1000, it should be 170. It cannot be. 1, 2, 3. No. Yeah, you are right. 1, 2, 3. It should be 17. Yes. So 17 milliamps. Now, everyone is agree that current should be same in a series circuit. If it is same, now, if I ask you I2, and again you will say, teacher, I2 must be same as the I1. Am I right? As per the rule of series circuit. Okay. Now let's check with the same formula which you people said it is correct. Yani Vs over R2. Check it. So it's 12 divided by 1.5. When I go for it, it is gonna be how much it will be? 8 milliamps.
8.
8 milliamps, not the same. So you look here, it is 8 milliamps, it is 17 amps, milliamps. So how it is same? Yani it is violating the rule which we just discussed in the previous one. Understand the point? So it means this is wrong. Understand? This is wrong. Those said, teacher, both are correct. Not. Only correct thing is the first formula, which is Vs over RT. So in a series circuit, whenever you want to calculate current, okay, either it is in R1, R2, R3, or whatever resistance you have, the very first thing you must get the total resistance first. First thing, calculate the total resistance. Then after, you will use the formula I1, or even you can say this is IT. To say IT is more accurate because IT is the total current, which is Vs over this one. And IT is what? IT is basically same as I1 is equal to I2 is equal to I3 is equal to IT. It is all same because of this. So this is the correct way to solve series circuit, because I know that my students will make mistake later on. So that's why I want to clear it right now here, right here. So it's so simple, but this type of problems happen later on. You people think it's we can just quickly get it. No. First of all, very first step to get RT, then calculate the total current, which is gonna be same. Now there is one scenario where this formula could be correct. Yani it could be V1 is equal to V1 over R1. Check this formula, what I just write it. I1 is equal to V1 over R1. That is correct. But do we have V1? Do we have V1? No. It is not given to me. But in some cases, we have given the V1. What is V1, by the way? V1 is the voltage across R1. Across R1, which is not given. If it is given, this formula will work. But because it is not given, it will not work. What is given? Total voltage. So total voltage is given. We need a total resistance. Then I can calculate the total current. And the total current will be the same current which will pass through R1, R2, and R3. Hope it is clear. Any question, any doubt?
Doctor,
Yeah, I didn't hear you. Repeat your question.
I have a question.
Yeah.
It's the V is the same as V1, V2, and V3 because it's a constant, right? So
No.
V1 is equal 12.
No. Who is speaking? Amna. Amina, see, how are you saying that this current V1, voltage V1, V2, V3 are same? How can you say? No. Listen dear, completely wrong concept. See, this is voltage, battery, correct? Two terminal of the battery. See how it is connected. It is connected to the combination of three resistances or not?
No.
Look now how it is connected. One end is connected here and they are connected in a series. So it is basically this 412 volt is supplying to all three resistances. This is supplied to all three resistances. Yani this 12 volt will split here, here, and here. And now how much voltage will drop in each the resistance? It will depend upon the size of the resistance. Getting point? And so the size of the resistance is already given to me. So in order to know how much is the voltage drop across R1, the formula is simple. Ohm's law, V1 is equal to R1 into I1. Similarly, for V2, it is gonna be V2 is equal to R2 into I2. V3 is equal to R3 into I3. By the way, all the current is same, but what is different? The resistance. So based on that, I can simply calculate that one. So a V1 will be what? I1 multiplied by R1. R1 I know, I1 already know. Then you will be getting that one. And when you will be getting, all voltage will be different, but their sum will be is equal to 12. Understand point now?
Yes, but why the current is the same?
Current is same. Yes, in series circuit, current is same, but voltage are different. Voltage are different. You can get it in a next slide. We are also calculating the voltage through all the resistances. Then it will be clear to you. But how are you saying that this same 12 volt will be across R1 and R2 and R3? No, it is 12 volt is applied to the combination of three resistance which are connected in series. See, you calculate the total resistance and how much you got? Total resistance 4.38. How much? 4.38? Just a minute. How much?
Yes, 38.
Yeah, 4.38K. So it was 4.38K. So RT 4.38K. Okay. And do you know this RT also called as a equivalent resistance? Equivalent, yani? So this terminal is the battery. And now we got the total here of that. So this circuit can also be drawn this way. This can be drawn this way, you know, and this is what? RT. And this is what? 12 volt Vs. So now I can say this terminal voltage is totally applied to across RT. So VT voltage across RT is basically now 12 volt. But what is RT? RT is a series, basically sum of three resistances. So the total voltage, which is 12, it is gonna be split into three parts: V1, V2, V3. Because resistance values are different, so V is equal to I into R. R is different, so V will also be different. Are you getting?
Yes.
So clear now? Or not clear?
Clear.
Yes, it's
All
clear. Thank you.
okay. All right. Okay. So next slide, we will also calculate the remaining things, like it is just total. And now see this one. So we are now also going to calculate this one. So you already calculated, we have given R1, R2, R3 and RT we have calculated. Vs is given to us. Now I am calculating IT, and IT formula will be what? IT is equal to Vs over RT. So when I calculate the IT, it is 2.74. And because it is a series circuit, I1 is equal to I2 is equal to I3, all are gonna be same. You know that one, right? Now, it is the time to calculate the different voltages. So V1, V2, V3. And I told you, we will be using a formula. Which formula? Ohm's law. V is equal to I into R. So this is general formula. Specific will be like that. V1, I1, R1. Bus. So what I need to do? I need to multiply I and R. Okay. And now look here. This is milli. This is kilo. So when I multiply milli and kilo, they will cancel each other or not? Milli means 10
No.
power minus 3.
No.
No.
You must convert first.
Okay. Even if you convert, they will cancel each other. The reason is milli means 10 minus 3. I am teaching you a shortcut also sometime. Okay.
Yeah. And positive 3.
Yes. So when I multiply them, it will cancel each other or not?
Yes.
Cancel
Okay.
each other.
See, they will cancel. So what will remain? Just this number multiplied by this number. Yeah, they are opposite. So I will use my calculator to multiply 4.74 with 0.68. That's it. Yeah. So answer is 1 point.
1.86.
Yes, correct. Yeah. So it is just to make your calculation easy by saying that kilo and milli will cancel each other. Similarly, we can calculate V2. This is V1. Similarly, V2. Similarly, V3. Yeah. So it is all okay. And I explained to you already that this is the supply. This is supply. So this is the source. This is providing 12 volts. So this 12 volt is consumed, is split. Some drop is here, some drop is here, some drop is here. And how much is the drop? We know that one. If you get the sum of these drops, how much it will be, do you know? Same as 12, because of supply voltage is equal to sum of the voltage drops. So what can we say? We can say Vs is equal to V1 plus V2 plus V3. This is what we call Kirchhoff voltage law. It is there in the physics, KVL. Am I right?
Yes.
So yeah, yes.
How? Okay, thank you.
Okay, is it clear or do you have any question?
Clear.
All right.
Clear, Doctor.
All right. Just okay, so this is Kirchhoff voltage law, which I just explained to you. So there are two ways to say that. Either I can say that supply voltage is equal to the sum of voltage drops, or I can also say that algebraic sum of all the voltages, supply voltage plus drop, is equal to 0. That can be also, we can also say this way. All right, let's see now. Time to calculate the power. So now we have IRV. So we can calculate the power. Formula you know already. Power formula. Yeah, P is equal to VI is the simplest one. Yeah, we can use it.
Yes, we know.
Yeah, it is the simplest one because it is just multiplication. So we can multiply.
Yeah.
So when you go for that, you will be calculating power. Yeah.
Yeah, 5.08.
5.08. Yeah, and it is milliwatt. This is the point. The unit is very important. How can you write W? Because current is in milli. Look, current is in milli, and volts in voltage. So because of this milli, when you just multiply 2.74 and 1.86, your answer is gonna be in milliwatt. This is important. Okay, be careful. Rest is okay. Yeah, just a product. So then you can easily calculate P1, then you can calculate P2, then you can calculate P3, and PT can also be calculated by the formula PT is equal to Vs into IT, total current. You know that one? Because the total voltage multiplied by the total current, that can also be calculated. All right, so I can also calculate PT. Now, if I get the sum of all the powers, if I calculate the sum of all the powers, yeah, P1 plus P2 plus P3, see how this power drop is coming. This is coming because of the total power. So total power is how much power we are supplying to this circuit, which is 32.9 milliwatt. So this total power is gonna be split into 3 resistance. Each resistance will drop the power. So see, the larger the resistance, larger the power drop. Smaller the resistance, smaller the power drop. You can see yourself. Am I right? This logic is also clear. Why milliwatt? Amal, it's very simple. You just use the formula P is equal to V into I, and our I is in milliampere, na? And V is in volts. V is in volts. So when you multiply I and V, it is gonna be in milliwatt or not? Yes. So this way, girls, we can calculate the total power also. All right. Let's see now. So in this previous circuit, girls, we have multiple loads, or what we can say multiple resistance. But we may have a situation where we have multiple sources. Here we have only one source, 12 volt, but we may have more than one. So see this scenario. If we have multiple sources, so multiple sources is like that. Okay, so this is like that. So voltage source in series, they are connected in series because one end is connected to the another end, and another end of this one is connected with that one. So it is connected in series. So when they are connected in series, the total voltage of the source is basically calculated algebraically. What does it mean? For example, let's suppose I say this is label A. Let's suppose this is label B. And I am interested to calculate VAB. Okay, so how I will be calculating this one? It is gonna be calculated algebraically, gonna be add algebraically. So I have to go from A to B. So when I'm traveling from A to B, I will be checking the very first sign of the source. What is the very first sign of the source when you are traveling? Positive, positive, 9. When I reach to second one, I will check again. Positive, I will put it again. Go next, positive, got it again. So in this way, I can say it is 27 volts. Clear? For example, if I say VBA, 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 I revert that. Yes, absolutely right. It is gonna be minus 27. Yes, because opposite going up to down, you know. So very first sign is gonna be negative here. They will add, but the sign will be negative at that. All right. Have you noticed that when you purchase some toys, so there is a remote control for the toys, and we need to put multiple batteries over there. Sometime more than one batteries, definitely sometime 2 or 3 batteries, they are connected over there. And you know why do we use it? Because each battery over there, it's like that, you know, remember, or yeah, everyone must be remember this one. The batteries are like that. So we use these battery to connect in the remote control somewhere. Each battery volts is 1.5. I'm talking about AA or AAA batteries, basically. So they are 0.5, 0.5. But in order to energize the remote control, we need 3 volts. So how do we get it? We connect series 2 batteries like that. So what will happen? This way we will be getting 1.5 plus 1.5. Yani this will be connected in the positive, negative, positive, negative. It is connected in a sequence basically. Then it is in series. You can see positive, negative, positive, negative, positive, negative. So when this is the order, they are gonna be add. If let's suppose mistakenly I just reverse the middle battery here, the polarity of the middle battery this way. Now, how much is the voltage?
For the first, but the reverse is gonna be minus 18.
Minus 18. Check it. 999. Okay. Majority is saying 9. Yani, what did you say this way? We can say VAB is equal to plus 9, minus 9, plus 9. So what happening here? one battery is cancelling the another one. Yani the two will cancel +9 only. Understand? This has happened. So if you have battery at home and you connect back to back, it will cancel each other and they will discharge quickly without doing anything because they are cancelling each other, voltage. This is something. Okay. So we'll see this thing of problems where batteries will be there, the circuit, multiple batteries. So what we will do, girls, we will check at that time if the batteries are connected in a way positive, negative, positive, negative. So they are gonna be add. If they are connecting like that, negative, positive, negative, negative, positive, like in this case, they will cancel each other. So we will see this one and then we will understand at that time. Okay. So I will give you an example of that one also later on, that it will be clear to you. So it's about multiple sources in the circuit. All right. So it is KVL, which I already explained to you. Kirchhoff voltage law. What it says, the sum of all the voltages drop around a single closed path in a circuit is equal to the total source voltage in that closed path. All right. So also we called it algebraic sum of all the voltages, including voltage, supply voltage and drop is equal to 0. That is also, different way of representation of the KVL, Kirchhoff voltage law. Also, the KVL applied to all circuits, but you must apply it to only one closed path. Yani, I can also apply KVL to a combination circuit. Yani, there, some component are connected in series, some in parallel. I can apply there, but I will choose a closed path. I will choose a closed path at that time. But for a series circuit, of course, there is only one path. So we can use series circuit easily. But if we want to use it in combination circuit, we need to consider, we need to identify, okay, this is the closed path, then I can apply over there. This is something. All right. So here we have already discussed this example, and what it says that the total of V1 plus V2 plus V3 is equal to Vs, which I already explained to you. Now, see this one. So one question for you, they are asking calculate the V3. Are you asking or giving answer? If you are giving answer, so be sure, na? It is mathematics, and mathematics, the good thing about mathematics, it gives you straightforward answer. If it is 13, say 13. Don't write question mark. Yeah. All right. Yeah, Mariam. Everyone, yeah, everyone is correct. Fatima, correct. Yeah, Mariam, Fatima, Fai, all are correct. Yes. So it's so simple. And which formula
13.
you use to calculate? 13, yeah. Which formula you use to calculate? KVL, Kirchhoff voltage law. Clear? So it's so simple, and we can calculate this way. All right. I can make this question little bit complicated. How can I make little bit complicated? If I place a battery here, anywhere, let's suppose here is one battery, two volts. Okay, do you know that the long line is positive, short line is, yeah. So it means this is positive This is negative. Now, girls, what else? Yes, now I am asking you V3. Good. Now it's change. Little bit change. 11. Okay. Let's see how you are calculating this. 15. 11, 15, 11, 15. Either plus 2 or minus 2. Is it like that? Okay. So what is the logic basically? Logic is you need to consider a closed path. You can start a point from here, let's suppose, and we will be following complete path. Or let's suppose I am starting from this point and I will end my journey here. So when I start this way, okay, so I can write the formula simply. What I will say, Kirchhoff voltage law. It says that algebraic sum of all the voltages around a closed path is equal to 0. Correct? So I can start this way from this point, girls. When I go up, so what is the sign of the battery? Negative 50. Am I right? I'm going up, this dot point and going up. Okay, what next? Plus 12, because this is the voltage drop. Is not a battery. It is the voltage drop in this resistance, but it is positive here. Next.
Plus 25.
25. Negative 2. Plus V3 unknown and equal to is equal to 0. Yeah, it is equal to 0. Now we can just simplify first this part, this one. So what is that? Minus 52 and positive is 37. So minus 52 and positive is 37, which is equal to 0, girls. Definitely V3 is also there. All right, now how much it will be? Negative
15.
15 plus V3 is equal to 0. Okay, we can flip now, and this, if not the flip, we can bring this 15 to the other side of the equal. So it will be
15.
V3 is equal to 15 volts. So for each and everything, there is a logic. Understand? Then it's there. Clear to all of you now?
Yes.
Yes. Yes.
Okay. So it is not going to take you much time. It is only 1 minute. Quickly I can write the value and calculate it. Then I can say, okay, similar. So this is multiple sources. And maybe I will give you another example with multiple sources later on. But for now, it is like, yeah.
Doctor, why you put minus 50?
Okay, minus 50. Because I told you, I am starting my journey like clockwise. I am going up, then I will go this way. Then I will go this way. Then I will go this way. So what is the
How
first?
to know the path? How to know the path?
You can choose any path, no problem.
Okay.
Okay, even if you want anti-clock, you can go for anti-clockwise. Value will be same. It will not change.
Yes.
Okay, you can try that one also. In the book also, if sometime we are calculating the current, if current is coming positive, so like what we assume the direction of the current is considered to be the accurate one. If the current comes negative, it means is that the direction which we assume, the actual direction is the opposite of that one, the negative sign of the current. But voltage you will be getting same. If you try, you can try yourself. Yani anti-clockwise, you can try this way. That will be the same thing. You will be receiving same values. Okay. All right. So you wanna take a screenshot what I explained? Have you taken a screenshot? But I think it's clear, huh? Simple thing. Okay, one more question. Some of the students ask me, teacher, give me some difficult one. It is wrong. Do I like? What is that? 5. Why it is wrong? If as long as you are getting same value, it is correct. Yeah, it is correct. 50 minus 12 plus 20. Yeah, it is also correct, 5. It will give you same result. Yeah, it will give you same result. Okay, but the logic is important. Yani what I explained, that is the, the logic. That's why the value is coming. So again, this formula you apply the logic, because you said to 50 is the applied voltage. Then you write the consumption there, which is absolutely right, which you said, yani 12 plus 25 and minus 2 you said because of the polarity change. That's why it's negative. So correct. It is okay. Also, guys, now see this question. So it is again, see, I did not design it. It is from the book. So this is something new. So, but is from the book. So you can get it yourself from there as well. But I just put it here. I feel that it is good to explain you here. So in this question, this is 42 question of the book. They are asking here to calculate the unknown quantities, girls. So what are the unknown quantities you need to calculate? So the red ones, basically, you need to calculate. The pink one or whatever. Think now and calculate it. If you have any question, you can ask me. And by the way, it's good practice now. Each one, everyone must have a notebook and pen and calculator with you, so that suddenly some question come, at least you can have practice. I may give you chance for the practice also. So now, any question or things are clear to you? Okay, Mariam is saying not a series circuit. All right. Check it again, Mariam. Do you think it is not a series? The reason, I would like to hear the reason.
There is a point where the current is divided.
Okay, Amal is saying it's parallel.
It's both series and parallel circuit.
Both series and parallel. Okay, where do you think it is parallel?
We
Which component is?
Yeah, we can build it, right, Doctor?
Yeah.
To make it.
What's that? Okay. Just you just think about this question. Just a minute, guys. I am just going to reset my router. Maybe there is a lagging. So in between that, you just think it will take only 1 minute. I will reset it so I can hear you properly. You think about this, no problem. Yes, girls, can you hear me?
Yes.
Okay.
Yes.
Yes, so okay. Yeah, so yeah, you were saying that it is a combinational, someone saying it is a parallel. Okay. So still same views. At black point, the circuit changes from series to parallel. Mariam, okay. Doctor, in my view, this is junction, but it is all in series. Okay. All right. This is okay. Black point. It's two series. Oh, it's two series. Okay. All right. Okay. Good. No problem. It's good to bring the problems whatever is it is in your mind so that I can find out some solution. See, first of all, what do you think? What is that voltage? 20 volts here. What's this? Is this battery? Okay. So what is that one? If not battery. What this voltage is telling you? Voltage between two black dots? Yes. Okay. Agree, huh? Okay. Wasted. Wasted energy. Okay. Okay. See. Basically, what is that? It is just a wire. It is not a something like current will flow. See, first of all, if current is supplying from this battery going here, it will reach here. Now, please tell me where the current will go. Will current go here?
No.
No. Agree. All are agree. Why it will not go
No.
here? Why no? It will not go here because of this wire is open. Agree?
Yes.
Yes.
All right. So if current will not go, where it will go? Will it go down or not?
Down.
All right. After down, where it will go?
To the right.
To the right. Absolutely right. Then after up.
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 All up. Then after
Left.
up, left.
Left.
Then
Up.
Up.
then down.
Down.
Then after
To the left.
to the left.
To the left.
And reach to the same point here, right?
Yes.
So everywhere current is same and there is only one path.
Yes.
Do you think there's any alternative path? Any current is splitting or dividing into two paths? No, there is only one path. So if only one path, it means is that it is a series circuit. Shape doesn't matter. So what is 20 volts? Yet I will tell you. Just a minute, Zainab. Okay. So see, I will make your life so easy after redrawing this circuit. I want to redraw this circuit to make the concept clear to you. See, this is the point. Let's say this is A. Let's consider this point. This is B. Okay. Now I am saying this is point A. This is point B. Correct, guys? Okay. Now from A, I am just following this path. I have 100 ohm. Then I have R3, R4, then R5, then I reach to B. So I will draw R2, R3, R4, R5. This is what? R2, R3, R4, R5 between A and B. Still, B is a junction, you know that. So I am just consider the down one, but we have here R1 connected. So same thing, I am connecting here R1, then battery is connected. I am connecting the battery and B is connected to the negative of the battery. Understand? Yes, Batul. right? So now this is A, this is B. Here is saying 20 volts. What does it mean? It means is that they are saying the voltage between point A and B is 20 volts. Yani they are telling you the voltage drop in the resistance R2, R3, R4, R5 is 20 volt. Understand the point? This is R6 also. This is the meaning of this 20. So how is it? Good, nice, very good, awesome. Huh? Why not 30? I see it is 20 because that's why it is mentioned 20 na. So how can I set 30? Because good, okay, I got your point, Jana. It means is that here because this is total is 30, correct? So total 30 is not across AB. There will be some drop which will be across R1 and some will be across R6. That's why. Yani the remaining 10 volts will be across R1 and R6. I don't know how much, but I am telling you. What I should repeat, Manar, please. You should repeat your question. What is not clear? Manar, can you hear me?
دكتور
Yes.
يعني 20 we will يعني divided at R2 R3 R4
R5.
ولا كيف؟
يعني it is given na?
ولا
It is
كيف؟
given
20
to
ولا ولا R1 it's 20 R2 it's 20 R3 it's 20 right؟
No. See, I just explained to you what I explained. I just consider this is point A. I tell na this is point A, this is point B. And what they are saying, see, this is here na. This point is just a drag here. And they said this is 20 volts. They said like that. So what I did, I just expand this line, which is like, snake like that. So I just stretch these 2 points. Just listen, think in a way. You hold the point B and hold the point A and stretch up and down. When you stretch up and down, you will be getting something like that or not. This is my point first. Understand? So this is something. And we have given that the voltage drop across these resistances, which is R2, R3, R4, R5 is 20. Drop is 20. But how much is the value of the voltage source? 30. Correct. So remaining 10 volts is basically gonna be drop in R1 and in R6. Now, is it clear?
Yes.
Okay. Yes,
Yes,
Mariam.
Doctor.
Okay, welcome. And it's a good practice for me. I need to redraw again and again. So that it looks simple to me. And once concept is clear, it will take only 2 minutes to calculate. So redrawing, yes, it is up to you. Fatima, complete slide. Complete slide. MashaAllah. Oh, okay. Let me check if I can do undo. So I will repeat after undo. Okay. Okay. So what I explain here? Okay, no problem. I am explaining now. Is it clear now, Fatima? My voice is audible? Okay. So what I explain, I am quickly explaining. I said, just consider these point A and B. Why do I consider point A, B? Because I have given 20 volt between A and B. A and B. What is that? It's just an extension of A. It is just extension of B. So this is AB. So I draw like that. So I see when I move from A to B, what is coming in to me? 100 ohm, which is R1. Then after that, what is coming? See now. Just a minute. Okay, so this is something. And when we go this way, so positive, positive, negative, positive, negative, positive, negative, positive, negative, you know, it's like that. So this way, yani this resistance are connected in a series. Yani this is what R2, R3, R4, R5. And what is given to me? This is 20 volts. Yani between these 2 points, we have 20 volts. Rest circuit, I am drawing as it is. See, it is as it is. It is R6, this is R1, and this is 30 volts. So it means is that yani resistance R2, R3, R4, and R5 is consuming 20 volts. Remaining 10 volts is basically across R1 and R6. Understand? Now we will calculate. So redrawing is just to make your life easy. After redrawing, now you look how can I solve it easily. So once it is clear, is it clear now? Redrawing is clear? Fatima? Can you hear me, guys? All of you?
Yes.
Yes, we can hear you.
Okay.
Yes, we can.
All right. So I just said, all right. So after redrawing, if it is clear, girls, what I need to do, I need to calculate some of the values now. So see, the current is everywhere same. Current is okay. Fatima, I tried calculating V6 and R6, which is 0.2. Okay, and yeah, V1 is just a minute. I think R6 is correct. R6 is correct. No, nothing is parallel there here. Nothing is parallel. Keep in mind, I am not teaching you parallel. It is everything is series here. This is completely series circuit. There is nothing. Amina, nothing is parallel here. Keep in mind. Everything is in series. Okay. Just wait. Yeah, this is okay. V2 is correct. 5. V2, it's so simple to calculate. Why? Because the resistance value R1 is given. How much is R1? 100 ohm. So when it is given, I can calculate V1, which is 2 volts. That is completely right. All right. Sorry, it's not V1, it is V2. Sorry, it is V2. So V2 is clear. Yeah. After V2, once you get it, all right. Can you calculate also V5? Look, V5 is already given, by the way. So V5 is already given. We can calculate R5 there. R5 will be 6.6 over 20 milliampere. Yeah. So how much it is gonna be? 330. Yes, you can keep noting, girls. Solution. This is R5. This is R5, 330 ohm. All right. So we have calculated two resistances, which is R1. Sorry, no, R5, which is 330, and we have calculated what? V2. Yeah, we have calculated V2 also. R6 also. Oh yeah, you can calculate the R6 as well. You know, how can you calculate the R6? Okay, tell me. R6. You know the power across the R6. Can you see this? Power is given. So if power is given, we can calculate it. Jana, is so simple. Current is given to you. Current is given 20 milliampere. Okay. And the resistance is given 100 ohm. So V2 will be what? Resistance multiplied by the current. Yes, Mariam, correct. So P6 is there. So we can calculate R6. And how much is R6? Okay, correct. So it is like R6 gonna be the formula P is equal to V into I. So we can calculate here what you want to calculate. Everything is possible. V6 is equal to P6 over I6. Is it correct? 112 milliwatt over 20 milliamps. P is equal to V into I. So milli cancel. When you divide it, how much it is coming?
5.6.
5.6 volts. Absolutely right. So girls, I already explained to you 20 volts is drop between these two. So remaining 10 is between R1 and R6. So can I say 10 is equal to V1 plus V6? Is it possible? Because these two voltages are sum. V1 any voltage across R1 and V6 is voltage across R6. All right, correct. So from here I can calculate now V1. What is V1? 10 minus 5.6. One of the students calculated earlier that one. That was correct. 4.4 volts. Correct? Yeah. So this way I have calculated V1, V2 and V6. Okay. Now coming to very interesting point. One more relation is given to you girls, which is that one. What is that? R3 is equal to R4. This is given to you. All right. So how can we solve this one when it is given? So, okay, values you already know. I'm just removing to create some space and I will write something here. Okay, so it is about what I'm gonna write. I'm going to write about 20 volts. What? It is about 20 volts. It is what? Can I say girls? V2 plus V3 plus V4 plus V5. Agree? $20 volts is given to me already across these resistances, and this is something. All right. Okay. Now V3 resistance R3 and R4 is same. If this is same, so these voltage drop will also be same or not?
Yes, the same.
All right. If they are same, let's consider V3 is equal to V4 is equal to VA. Any arbitrary value we are just considering now. So when I say it is VA, so will it be VA, something like that? 2VA, because twice. Is it clear? All right. Now, so from here, I will say 2VA is equal to 20 minus what? V2 plus V5. Is it correct? Getting everyone? All right.
Yes.
All right. So please focus. 20 minus, do you know V2? Yes. Do you know V5?
Yes.
How much?
6.6.
All right. Now, then 20 minus, how much it will be, girls? 8.6. All right. Now, how much it will be?
11.4.
11.4. Now, what will be the VA? 11.4 divided by 2, which is
5.7.
5.7 volts. So, and what is VA? V3 is equal to V4. This is something. Now, Tell me, is there any value which is remaining, or we have calculated everything? I guess we have calculated all the voltages. V4 is remaining, huh? No, we have calculated. Yeah, R3 and R4 is remaining. Okay, what is R3? R3. Okay, it's so simple to calculate all the resistance. You know how it is simple? Because first of all, look, have you calculated all the voltage? V1 is clear, V2 clear, V3, V4, V5, V6 all clear. So which resistance you want to calculate? Tell me. Which one you said, Mariam? R3. Okay, so for R3, what is the formula? V3 divided by I3, and I is everywhere same, correct? And V3 you just calculate. How much is V3? 5.7 divided by 20 milliampere. Okay, so how much is gonna be? You can get it now.
0.28 kilo ohm.
0.28 kilo ohm, or 285 or something, whatever you can check it.
Yes,
Ohm. Okay, this is it. So this is R3, and it is given there R3 and R4 are same. So why should I spend my time? I can directly say the same thing here. Clear? Okay. Okay, clear? Yes. Now I am free here. Anyone have doubt, I can reply to you.
Doctor,
Yes.
we said that V3 equal V4 because of the relation given, R3 equal R4.
Yes.
Okay.
Okay, because you know the current is same already. We know it's series circuit, and now they are saying resistance is also same. When resistance is same, current is same, definitely voltage will also same. That's why we said like that. Okay. 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 It's a series circuit because it's open after point A, right? See, yeah, you know, this is not a point, Mariam. It is not a point. It is just a single, you know, reference line drawn. It is not a part of a circuit. Keep in mind. Okay, I'm just, girls, can I erase everything, or you want to take a screenshot? Then I will erase. All right.
Yes, Doctor.
Oh, all right. Listen, so I will just explain a few basic also. Mariam is saying that, doctor, it is because, see Mariam, this wire, okay, let me draw the line. This wire is nothing, just a label, just an extension to make it a square shape, something rectangular shape. Just tell you that is the point, yani this point and this point, the voltage is 20. Otherwise, this is not a part of a circuit because it is open here. Everyone can see this is open here, and current will not go in the open, you know, space. Again, this is open, current will not go. So it is just, you know, sometimes we use it to tell, yani this point. See, if I want to tell you that from this point to this point, the voltage drop is 20. How can I tell you? Easy way. So the easiest way is what we do, we just draw a line. We draw a line here and we say positive, negative, yani this is the drop, and it is here 20 volts is there, something like. It means is that between this point and this point, there is a 20 volts drop, but it is not a part of a circuit. It is because of it is open. For example, maybe in future you will see these things. I just wanna give you idea. Now, it is a combinational circuit. It is not no more series. No more series. The reason, the current will flow from here to here. Then when it reach here in the junction, it will split into two parts. One part, another part. So here we cannot say it is series circuit because some component will be in series, some component will be in parallel. Okay, you will understand with that time. So this will be going here and this current will flow here, then it will meet here, and here from here, yani this one is in series because same current is flowing. This one is in series because of same current. So this complete twisted arm is in series, but this combination from here to here, it is gonna be parallel with R7. You will understand later on. Maybe if you understand here is good, but we will be discussing later on. Okay, this is gonna be parallel. I will inshallah give you example later on. So for now it is clear. Okay. All right. See, I told you, you people need to explore more examples, more practice questions. There are too many you can find in the book. If it is not there, YouTube is there. You go there, just find it, some series circuit examples. You will see a lot, because the limitation, girls, online. It is not so easy to write the things. Okay, I'm trying my level best. Inshallah, I will keep trying. But your effort is more important here, because practice you need to do. If it is on whiteboard, I am teaching you there in the class, that I can draw quickly. I can give you more examples. It is so easy for me. But here is difficult to draw the things again and again and explain to you. So your efforts is very important. That's why I bring this question here, because itself it is a complicated, but it is covering a lot of things. So one question, if it is clear, inshallah, everything will be clear. All right. Okay. So yes. Next is voltage divider rule. A voltage divider rule is again applicable for the series circuit. This chapter is all about series. We are discussing series. What voltage divider rule says, girls, as you already know now, this is the total voltage, supply voltage, which I am giving to this circuit. So this voltage will split into R1 and R2. You will be agree on it. You know that this 12 volts will be now is gonna be divided between R1 and R2. So girls, there is a voltage divider rule. There is a formula which is mentioned here, written here. You can read it. I'm just directly writing the formula. Yani, by using that formula, I can directly calculate how much is the voltage drop across R1 and R2. So let's suppose the voltage drop across R1 is V1. So V1 will be, formula is that. Okay, what is the formula? The resistance in which you are calculating the drop, which is R1, over the total resistance, which is RT, multiply by, not total, it is gonna be total, multiply by Vs. That's it. So this is called voltage divider rule. And it is so simple. Yani V1, I want to calculate V1. So I have to take R1 over RT, yani total. And what is the total? You already know. RT will be R1 plus R2, because R1 and R2 is in series. Both are in series basically. They are in series. So it's simple. So I can calculate. Similarly, now tell me what will be the V2 formula?
R2 over RT times Vs.
What it will? Into Vs. That's it. It's so simple, bus. Okay. If you calculate the V1, is there any other way to calculate V2 other than this formula? Yes. What is that? Can I say Vs? Yeah, Vs minus V1. Yes. So Vs minus V1, because of the rule is this, KVL, Kirchhoff voltage law. We can also apply that one. And this is voltage divider rule. So sometimes question come, girls, apply the voltage divider rule and calculate the voltage across this resistance. So this way we can calculate. Okay. Let's suppose, just take a real example of it. This is already given. I explained to you. Now, this is the example. So what is the voltage across R2? So here, one way could be the general way, which I explained to you. You need to calculate first total resistance, then calculate the total current. Then after getting the total current, you can calculate V2, which will be V2 is equal to R2 into I2, correct? Or we can simply apply the voltage divider rule, which is very simple. Okay, yeah, it is gonna be 8 volts. Yeah, it's so simple. Just you need to write V2, which is R2, okay, which is 10 over the total multiply by 20. That is 8 volts. If I ask V1, so you will say 20 minus 8, teacher, it is 12 volts. This is V1. So easy. And see, if you just add 8 plus 12, it is gonna be 20. That's it. It is what? Kirchhoff voltage law. That's it. Okay.
Yes, clear.
Okay. Okay, this is what they are saying. Just voltage will be like that. And okay, let's see this one more question. So point A and B, yani VAB, you need to calculate VAB. So VAB, just a minute. Yes. VAB. What is the formula first? Between VAB, what is the resistance?
1.
R1. So I can also say it is V1. Clear or not?
Yes.
Yes. But so write the formula.
Yes.
It's very simple. R1, RT.
RT
Yes.
multi VS.
Yeah, VS. Bus. Simple. So put it values 1 over the total. So you can get total separately. So 9.2, 9.5, 12.5. Multiply by 25. By the way, this is a ratio. Both are resistance up and down. So all are in kilo. They will cancel each other simply. So ratio doesn't have any unit. You know that. So R1 is already 1 kilo. So it will cancel. Now it will go 2 times 2 volts.
Yeah, it will 2 volt.
It will be 2 volts simply. Okay. So it's very simple. So now, you know, that's why we use voltage divider rule, because it's make life easy rather than calculating the current, then multiply, then get. So it helps us to basically simplify the equation. Yeah. Now, similarly, next is VAC. VAC.
R2
Yes,
over
Vada.
RT multi VS.
Okay. So are you going to take R2 because it is AC, AC, and this is A, and this is C. And if you look between these A and C, there are 2 resistances. They are in series. So Gada, correct, you are right. We can say R1 plus R2 in bracket over RT multiply by VS. So that will be, yes,
18.4.
Yes, 18.4, correct. So 12.5 multiplied by 25, then it will go 2 times, 18.4 volts. Correct. Similarly, we can also get VCD. VCD is also possible. Okay. So this way we can calculate anything. So it is, you know, help us basically to calculate the things. Okay. All right. Okay. Just one more question, then inshallah things will be very much clear. Okay. So this is the question. But I think there is circuit is missing. Just wait. There is a circuit. It should be here. I have to save it. You can also draw this circuit. Maybe you people are also not having this circuit. So just keep it here. And this is the question now. All right. Mariam, what is that? Why it's not negative? What is why it is not negative? Because you are calculating VAB. VAB. So A is positive or not? Similarly, in the second one, you are calculating VAC. Yani A is the reference point. If I calculate VBC, yeah, VBA, that is negative because B is negative here. When I say VAB, it means is that I am going from A to B. It's like that. I explained to you earlier. What is the first polarity of A? You can check here. What is the polarity of A? Is this positive or not? This one. Yeah. So it is positive. Answer is positive. In both the case, you are calculating VAB, VAC, and A is positive. So it is gonna be positive. Clear or not? Not. So how it will be clear? Why do you think it's negative? Tell me first. Why do you think it should be negative? You mean the final answer is negative? No, which final answer? I said final answer is, I calculated final answer. All final answer are positive. There is nothing negative. Don't bring negative views in your mind. All are positive. Because the above sign is negative. Yes, because the above this is positive. Nah? This is A is positive. A is positive. So I'm calculating value voltage between A and B. So I'm going from A to B. When I'm going from A to B, it is positive, it is negative. So it is gonna be positive, simple. Second case, I am going from A to C. A is again positive. So first reference point is positive. So value is gonna be positive. I am not applying here KVL, Kirchhoff voltage law. If you go this way, this is negative, positive, and this is positive, negative. You know that? So when we go this way, then in this case, it will cancel this voltage because of the polarity change. This is negative, positive. It is positive, negative. Why positive, negative? It means is that the voltage across this one, when current enters from here, it is high. When it leaves, it becomes low because it drops some voltage. Similarly, it happens here. That's why the first sign is always positive and negative here in the resistance. But when we are considering the battery, so here is negative, it is positive because the voltage is increasing here. Voltage is increasing because this is supply voltage, it is increasing, but here is decreasing because resistance is consuming the power. That's why. So your negative become positive now. Very good. Good. All right. Okay, look for this question now. First one. Let's see who will solve this question.
I have this. If we go from B to A, Also positive or negative?
That time negative, because B is negative. This is negative, see? So if I am asking you VBA, yes, so because B is the reference point and which is negative here, that is gonna be negative. Okay, at that time there will be negative sign. Okay, don't confuse with negative positive. It is not gonna be effect. It is given to you positive here. So I am just calculating VAB. So what is the, I just explained to you now that the first sign is important. So when it is VAB, so what is the sign of A? That will be the sign of your answer. Simple. Okay. Okay. Look for the first question. Maybe all students already solved it. You people are discussing negative positive. See, mashallah, everyone solved. Amal, have you solved? Batul, Aziza, Ashwaq, maybe everyone solved the first question. Yes, have fun, mashallah. 8 volts. Yes, very good. Okay, what about others? Okay, Shahad, how much? 8 volts? Okay, good. So, should I explain or is this clear to everyone? First question. V1 is equal to R1 multiplied, it's clear. Okay, very good. 2V1 plus V2 is equal to 12. Okay, 2V1 plus V2 is equal to 12. But why, what is V1? Do we know V1? This is the point. Okay, maybe you got it. Let me just explain this one. Let's see. So what is given to me, girls? See the condition. So condition is given. They are saying that, what they are saying, R1 is the twice of the size of this one. Correct? So it means, can I say R1 is equal to 2R2? Are you agree with the statement given?
Yes.
Okay. Now, what is the voltage across R1? Yani they are saying what is V1. So V1, formula VV will be R1 over RT multiplied by VS. Everyone agree, right? This is we know already. Okay.
Yes.
Now can we calculate the RT? RT. So for the RT
R1 plus R2.
Yeah, R2. And from the relation, can I put R1 is equal to 2R2?
Yes.
Okay. So can I say it is now 3R2? Okay. Yes. Now put here. Again, put the value of, sorry.
How we can put 2R2? It's different value. 1 and 8.2 and 3.3.
No. I'm talking about the above question. This first down question is finished. We are talking about the upper question. An upper circuit is there. Circuit is different. This is not about the below one. First question at the top. Clear?
Okay, Doctor. Yeah,
Okay.
clear.
Okay. So now here put the R1 in the formula, which is R2. I can say upon 3R2 multiply by VS, which is 12. Girls, R2 cancel out. Okay. And 3 will cancel this 12 4 times. Then 4 multiplied by 2, it is 8. 8 volts is the answer. Now clear to all of you?
Yes.
What is this one? We can just divide it by 3 and just multiply by 2 to find R1. That the way we find both R1 and R2. No, I don't know how you are saying this one. You know, this time R1, R2 value is basically there is a relation between them. You can have any value of, you know, these resistances which will satisfy this condition. Yani all the time you will be getting 8 volts if you maintain this relation. What is that relation? You know, if I keep R1 is equal to 2 ohm and R2 is equal to 1 ohm, same voltage you will be getting, because there is a relation now. Similarly, if R1 is 4 ohm, R2 will be 2 ohm. Relation is similar. Yani, what is this relation? R1 should be twice of R2. So in both the condition, it is true or not, girls? Even a lot of conditions are possible. Yani R1 should be double of R2. As long it is true, we will be having V2 8 volts all the time. You know this one. So it is based on the relation actually this time. So values cannot be calculated of the resistance R1 and R2 until they just give some more information. Yani, let's consider R1 for now. If they said R1 is 3 volts, so if R1 is 3 volts, so we can get 3 ohm. So if it is 3 ohm, so we can say R2 is 1.5, any half of it. It's like that. Hope it is clear to everyone, right?
Yes, it's clear.
All right. So can we stop now?
Yes.
Okay. Now we just stop. Inshallah, we'll continue tomorrow. And before that, better you just go through some of the exercises. There are a lot of. So tomorrow, inshallah, we'll close this chapter. Your queries could be addressed tomorrow. Okay. So bring your queries as much you have. I will finish first chapter and I will address your queries tomorrow, inshallah. Okay. Bye-bye. See you, inshallah, tomorrow.
Thank you, Doctor.
You are welcome.